know. What's the difference between series and parallel again?
I have no idea. I thought you knew how to do this.
No, I thought you did.
No.
I can help. I have here some prepared diagrams.
Perfect.
A parallel and a series. Let's look at parallel. There are some key differences. In particular, the voltage in a parallel circuit is consistent throughout. For example, if we have a 12-volt battery, the voltage difference from here to here will be 12 volts. And from here to here, 12 volts. And likewise up here. By the property of a parallel circuit, that the voltage total is equal throughout. Series, on the other hand, if you have a 12-volt battery, the voltage difference will differ. The voltage difference will sum up to equal 12 volts. So from here to here, it might be 4 volts. From here to here, 4 volts. From here to here, 4 volts, for example. However, there may be some different properties intrinsic of our little light bulbs that will change that. Is that clear?
Not really. Yeah.
Well, perhaps a demonstration.
That would work.
We have here our parallel circuit, conveniently modeled after our diagram. We have our batteries. These are 8 1.5 volt batteries connected in series, which equals 12 volts. If we connect that to our parallel circuit, each of our light bulbs should burn pretty bright.
Can I connect it?
Yes. And that works. However, you'll see our little guy over here died because he got burnt out. But let's see if our parallel circuit holds true to the properties that we've just mentioned. One interesting thing to point out is that in a parallel circuit, even if one of the connections is messed up, the circuit will still light. So we have almost 11 volts. That's good. And here we have the same value, almost 11 volts. So that's true. And if we go up here, it should be the same. And it is.
Interesting.
Unfortunately, this little
guy
died. So how does our series circuit work? Well, let's see. And what we have here is an oops. This guy is burnt out. But another interesting thing about series is if one connection's lost, the whole circuit is lost. But if we just change it around a little bit and make a series out of these two, just a moment, this is a tough alligator clip.
It's those muscles.
Yeah, gotcha. Now, the voltage difference from here to here and from here to here should equal 12 volts.
That's so cool.
So, here's our voltmeter. And what do we have from the first spot? 5.74. And here, 5.92, the sum of which equals very close to 12 volts. Is that a little bit more clear?
Perfect.
Okay. That's our physics project, spring of 2012. I'm Kenny Savolto.
I'm Ashley LaRose. I'm Katie.
Phil Lee.
And I'm Jasmine.
Woo.